Hi, this is the continuation of the previous video. So we have to discuss microservices. Now let's imagine our application become huge and we have authentication, users, orders, payments, notification, search, recommendation. Everything is currently inside one application. That's a monolith, and there is nothing inherently wrong with the monolith. In fact, monoliths are often a great starting point, but as the organization and system become larger, we might decide to split the application into separate services. For example, auth services, user services, order services, payment services. Now each service can potentially be developed, deployed, and scaled independently. This is called microservice architecture. But here is another important lesson. Don't hear microservices and think like microservice equal to better. That's not true. Microservices can introduce their own complexity. Now you have network calls, service discovery, distributed tracing, retries, timeouts, authentication between services, data consistency problems, deployment complexity, monitoring, and much more. So it's a trade off. If you are building a small application with 3 developers, you probably don't need 30 microservices. So the complete picture, now let's put everything together. For example, we started with client, then client goes to server, then database, then traffic increased. We added load balancer, then we added multiple services, then our database became bottleneck. So we added read replicas. Then frequent reads were putting pressure on the database, so we added Redis Caching. And then background operations were slowing down requests, so we added message queues, Kafka. Then we had large media files. We added object storage plus CDN, and eventually our application become large enough that we might consider microservices. So our architecture now looks like something: client that will call the CDN and API gateway, then the load balancer, then multiple application servers, then the Redis cache, then the database, and alongside that Kafka message queues will go to background workers, and for large files it will go to the CDN and object storage. That's look complicated, but remember, we did not start with this architecture. We arrived here because we had problems, and this is the most important lesson I want you to take you from this video. So how actually to approach any system design questions? When an interviewer gives you a question like design WhatsApp, don't immediately start drawing, and that's the wrong approach. Instead, follow a framework. First, clarify the requirements. Ask, what does the system need to do? What features are in scope? Who are the users? And estimate the scale: how many users, how many requests per second, how much data, how much storage we need. And after that, define APIs and major entities. What does this client need to communicate with? What are our main database models? Start with simplest architecture: client, server, database. Find the bottlenecks. What break first? Is it that CPU, memory, database, network, storage? And then scale the bottleneck. Maybe we can add load balancing, caching, replication, sharding, queues, CDNs. What exactly solves the problem? And discuss the trade-offs. Why did you choose Postgres instead of MongoDB? Why Redis? Why Kafka? Why async processing? Why eventual consistency? And then discuss functional and non-functional requirements. There are two categories of requirements that you should be comfortable with. The first is functional requirement. This describe what system does. For example, WhatsApp: user can send message, user can receive message, user can create groups, user can see message status, and so on. Non-functional requirements, for example, high availability, low latency, scalability, readability, reliability, and durability. These are extremely important in system design, because two system can provide exactly the same functionality, but one can handle 100 users at a time while another can handle 100 million users at a time. The difference is architecture. Let's discuss the biggest mistake beginners make. uh, the biggest mistake I see beginners make when learning system design is trying to memorize architecture. WhatsApp uses this, Netflix uses this, Uber uses Kafka, Instagram uses databases, and so on. You need to understand why. Why do we need cache? Why do we need queues? Why do we need replication? And that's and if you understand the problem, then you can derive the architecture, and that's much more powerful than memorizing the diagrams. So what's next? If you are completely new to system design, don't try to learn everything in one day. I would recommend learning in this order. For example, first, networking basics. Understand HTTP, TCP, DNS, CDNs, reverse proxies, then databases, SQL, NoSQL, indexes, replication, sharding, then caching, Redis, cache strategies, cache invalidation, then scaling, horizontal, vertical, load balancing, then distributed systems. This will have consistency, availability, cap theorem, distributed transactions. Then you can learn about the async systems, messages, Kafkas, pub sub model, event driven architecture, and finally real system design. And this will include like design WhatsApp, YouTube, Instagram, or e-commerce platform. And just don't just watch these, try designing by yourself. So if you are new to system design, I hope this video made one thing clear. System design is not about memorizing all those things or a bunch of fancy architecture diagram. It's about starting with the problem, understanding the requirements, estimating the scale, building the simplest problem solutions, finding the bottlenecks, and then introducing the right technology to solve these bottlenecks. That's the mindset you need, and that's exactly what we are going to do on this channel. We are not going to draw system design diagrams, we are going to understand why those system designs are that way, and whenever possible we will actually going to build them. In next video we are going to take one of the most common system user problems, maybe URL shortener. Okay, so we will start with that implementation, and then we will scale it and the way potentially billion requests. So if you want to learn system design practically, subscribe to me, and I'll see you in next one.